Hey guys, welcome to week number 2 of the ACE or IB math exams in 10 weeks. If you didn't watch it yet, if you didn't go through the exercise list yet, week number 1 was already posted, of course, and you can find the links for both the video and the exercise list from week number 1 in the description of this video. I'm Bruno, the IB math teacher. If you do not know me, I've worked as the HL math teacher in one of the most prestigious IB schools in Brazil, and I've also worked as an IB math examiner. And for this May 2026 cohort, I've decided to launch a 10-week series with carefully crafted, challenging IB style math questions from paper 1 and paper 2 to better prepare you for the upcoming IB math exam. You can download the exercise list in the description of this video. The link is there. Do know that each list is composed of 5 different exercises, one from each topic: number and algebra, there's functions, trig, probability and statistics, and then lastly calculus. And do also share this link to this PDF and also the YouTube video with your friends so you guys can practice together. By the way, studying by yourself is not as fun as studying with your colleagues, so maybe that's a good idea. Now, let's tackle week number 2 in this 10-week series, ACE or IB math exams in 10 weeks. Let's get to it. All right, so in this first exercise, we have a sequence of terms, which is a arithmetic one, which involves logs, natural logs. Now, the first thing that we could do in order to make this more approachable is to rewrite these terms. So we can see, for example, that this first one using log properties. And which property am I talking about? The quotient. It could be rewritten as the natural log of x squared minus the natural log of y cubed, which by using another property, the exponent one, could also be rewritten as natural log of x squared minus 3 ln of y. And I just dropped the exponent of y because the ln of x squared is constant amongst the other terms. So going to the second one now. We can rewrite this as ln of x squared minus 5 ln of y. And this one as ln of x squared minus 7 ln of y. Now the common difference, which is question A, can be found by subtracting u1 from u2 or u2 from u3, whatever you prefer. So let's do u2 minus u1, which is ln of x squared minus 5 ln of y minus ln of x squared minus 3 ln of y. And this is equal to negative 2 ln of y. So that's our common difference. Now we can jump to question B. The sum of the first 10 terms, meaning S10, can be written as some constant times ln of x plus some other constant times ln of y. What are these constants? So we need to remember, or not actually remember, but we need to use the formula for the sum of the first n terms in an arithmetic sequence, which can be found in the formula booklet. When we have the last term, meaning the 10th term, this is the formula that we use. When we do not, which is the case here, we use this one. Meaning that for question B, we have s of 10 as 10 over 2 times 2 times u1, which is the first term, ln of x squared over y cubed, plus n minus 1 times the difference, negative 2 ln of y, which means that we have 5 times 2 times, and then we can expand this log, ln of x squared minus ln of y cubed, plus 9 times negative 2, which is the same as negative 18 ln of y. So we have 10 times ln of x squared minus ln of y cubed minus 18 times 5, 90 ln of y. Now, by rewriting this as 2 ln of x and this as 3 ln of y, we get 20 ln of x minus 30 ln of y minus the 90 ln of y. And the final answer is 20 ln of x minus 120 ln of y. Therefore, our A is 20 and our B is negative 120. And that's all there is to it. All right, so in exercise number 2, we have a rational function. One of the things that makes this exercise a little bit more difficult is the fact that we do not know what k is. We only have its range. It's somewhere in between 2 and 3. And that makes for a slightly more challenging problem, especially when you're graphing this function. But let's take it step by step. Question A. Given that f of x is 2 minus x minus k over x plus k, show that this f of x can also be written like this. And it's much easier to go from here to here, meaning proving that 2 over x plus k minus 1, which by the way can be rewritten using a common denominator, we need to show that we're going to get exactly here. Now, we have in the numerator 2 minus, and given that the denominator here is 1, if we multiply both the numerator and denominator by x plus k, we get 2 minus x plus k in the numerator, which means exactly what we had before. So 2 minus x minus k over x plus k. Now the word hence shows that we need to use the answer that we got from question A in question B, which means in this case it should give you a slight hint, meaning that it's much easier to see the transformations if you think about f of x like this, as 2 over x plus k minus 1. Now what's the parent function here? Well, it's g of x, which is 1 over x. And we have three transformations. Number one, a horizontal shift k units to the left, which produces 1 over x plus k. Transformation number two, a vertical stretch by a scale factor of 2, which gives us the following. And transformation number three, a vertical shift 1 unit down. Now let's list all these transformations right here. And do remember that the transformations which involve x, they come before the ones that involve y. That's why the vertical shift 1 unit down was the last one. So horizontal shift k units to the left, vertical stretch by a scale factor of 2, and then lastly vertical shift 1 unit down. And now we proceed to the sketch. Now let's base our analysis in the transformations that we have starting from 1 over x, which is the parent function. If the goal was to graph 1 over x, you would have a vertical asymptote, which is x equals 0, and also a horizontal one, y equals 0. Now this is, of course, if the function was 1 over x. Now let's take into account the transformations. We have a horizontal shift k units to the left, which means that our new vertical asymptote will be x equals negative k. Then we have a vertical stretch by a scale factor of 2. And given that I didn't place any scale in this graph, I can just copy the same one. It's important to notice that the vertical asymptote will not change, which is the same case for the horizontal one right now. But on the next step, which is a vertical shift 1 unit down, now in this case, we will have a change in the horizontal asymptote, which will be y equals negative 1. So we have the following curves. Now we can also find the intersection with the x-axis, which is when y equals 0. So we have 2 over x plus k minus 1 equals 0. 2 over x plus k equals 1. If you cross multiply, you get 2 equals x plus k, which means that x is 2 minus k. So the coordinates of A are 2 minus k, comma 0. And for point B, which is the y-intercept, we can evaluate f of 0. So for x equals 0, we have 2 over 0 plus k minus 1, which is 2 over k minus 1. So we have 0, comma 2 over k minus 1. Now we can jump to question D, which is to find the domain and the range of this function. The domain should involve all x values with the exception of the vertical asymptote, which means all real numbers except for negative k. And for the range, excluding the horizontal asymptote, we have all real numbers except for negative 1. And now we can jump to question E, which is to find the composite function f of x. And with that, stating what is the equation of the horizontal asymptote. Now, don't do what I'm doing right now. So you want to be very organized when you're writing your answers in the IB exam. I'm just drawing multiple graphs and multiple diagrams to explain this with more detail, but you want to answer everything sequentially. Now, what is f of x? Given that this is our f of x, we're going to plug in f of x in every x that shows up in f of x again, which is, by the way, only in one place, which is right here. So we have 2 over f of x plus k minus 1, and instead of this green box, obviously we're going to write f of x again. And to simplify this, we can use a common denominator in the denominator, meaning x plus k in the denominator, which will give us 2 plus this negative 1 plus k times x plus k, all this minus 1. And this gives us 2 over 2 minus x minus k plus kx plus k squared, all that over x plus k. And we can multiply the 2 in the numerator by the reciprocal of this fraction, which gives us this. And simplifying it a bit more, we need now to combine this fraction with the negative 1, which means writing everything over the same denominator, which means that we're going to have 2x plus 2k minus 1 times everything that's in the denominator here. So minus 2 plus x, we need to flip every sign, plus k, minus kx minus k squared, which means that we have 3x minus kx plus 3k minus 2 minus k squared, all that over negative x plus kx plus 2 minus k plus k squared. Now, one thing that was asked from the exercise was to come up with the equation of the horizontal asymptote. And we know, or we should know, that whenever we have a rational function, and let's call it h of x, with coefficient a multiplying x and coefficient c multiplying x in the denominator, so a in the numerator and c in the denominator, the equation of the horizontal asymptote is y equals a over c, the leading coefficients. So if we rewrite this function by finding the coefficients that multiply x in the numerator and denominator, 3 minus k over here and k minus 1 in the denominator, and the other terms, they do not really matter, well, at least not for this step of the exercise, then we know, or we can see, that the equation of the the horizontal asymptote is y equals 3 minus k over k minus 1. So this is the horizontal asymptote. And there you go, kind of a long exercise. All right, so we're almost halfway there. Exercise number 3, one that involves trig. Edna loves going to the beach and finds it relaxing to stand in wavy water. We can see that the water is rising and lowering as time goes by. And this is a very typical application of a trig function, given that it oscillates, it mimics a periodic behavior. And trig models, they have the following shape. We have a constant a, which represents the amplitude. We have a constant b, which represents the period in quotes, because the period is actually 2 pi over that constant, which, by the way, if you're wondering, it also means that b is 2 pi over the period. So these are the same. We can also see c over here, which represents a horizontal shift of the graph of this function, and this d, which is the vertical shift, which also represents the principal axis. Now let's extract some information from the exercise. We know, for example, that whatever happens again after 3 seconds, which means that the period is 3, which allows us to calculate b. So b is 2 pi over 3, which, by the way, is question A. Now, before finding the other constants, let's represent this graph. We have this person's feet, and this is my attempt of drawing feet. This is the person's knee. And we know that after 1.1 second, and then again every 3 seconds, meaning the next one will be at 4.1, the level of the water will be at the person's knee, which is 55 centimeters from the ocean's floor. We also know that the ankles are 12 centimeters from the ocean floor. So this is what the curve will look like. In order to find this principal axis, which is the vertical shift, we do max plus min over 2, meaning max plus min height, which in this case gives us 33.5. And now the amplitude can be found by calculating max minus min over 2. And we know that A is positive. It was given by the exercise. That piece of information, was given by the exercise. So we have 55 minus 12 over 2, which is 21.5. So up to now, our model looks like this. D of t is equal to 21.5 cosine of 2 pi over 3, t plus c, plus 33.5. Now, given that at 1.1 seconds, the height is 55, given that the water is touching her knees, you can use the numeric solver with this function and this point right here, which means that you're going to throw in the point 1.1 comma 55 into the function. So 55 equals 21.5 cosine of 2 pi over 3, 1.1 plus c, which you're going to need to replace it by x in your calculator, plus 33.5. When you plug it into the numeric solver, make sure that your interval is from 0 to a big positive number. Don't use negative numbers in your interval because the question is asking for the smallest positive value of c. And when you do so, you should get c equal to 1.9. Now, one question that you might have is, how would I do that if this was a paper 1 question, which could be the case for this exercise C? Well, you would need to solve this algebraically. You would subtract both sides by 33.5 and then divide both sides by 21.5, which means that you would get 1 equals cos of 2 pi over 3, 1.1 plus c. And then you need to think, what is the arc that gives you a cosine of 1? And there are infinite answers for that question. There is, for example, 0 or 2 pi or negative 2 pi and so on and so forth. Now you should divide everything by 2 pi in order to get rid of this. So you get negative 1, 0, 1, all the way up to infinity equals 1 over 3, 1.1 plus c. Then you multiply everything by 3, which gives you these results. And then you subtract 1.1 from each one of these options, each one of these solutions, meaning you would get negative 4.1, negative 1.1, and then the first solution, which is positive, which is the correct one. Therefore, the first positive number is 1.9. So this is much harder than using the numeric solver, of course. Now for question D, there's no way to do this without the calculator. You need to find the amount of time within the first 15 seconds, meaning your interval will be much bigger where the water is above 40. So graphing the function and graphing the line y equals 40, you should find this interval by calculating the intersection between the line and the curve. And whatever you get as the x values here, which are 1.70 and 0.497, you find the difference between the two, which is the interval, 1.206 dot dot dot, and you're going to multiply that by 5, given that there are 5 of these intervals, until you get to 15. So you have 5 times 1.206, you get approximately 6.03 seconds. All right, so a nice probability question, one that involves a little game. These are usually the trickiest probability questions, the ones that involve multiple items in the same question. So let's see what's happening in this scenario here. So we have a bag which contains n marbles. 2 of these marbles, they're blue, 3 are red, and all the others, they're all black. We don't know how many exactly, but they're all black. Lara plays a game in which she randomly draws marbles out of the bag, one after another without replacement. This is very important. Whenever she gets a red marble, the game is over, which means that if we're trying to find the probability in terms of n that the game will end on her first draw, well, on her first draw, she needs to draw a red marble. How many red marbles do we have? It's 3. So we have 3 red, 2 blue, and some which are black. We're going to state as a function of n how many black ones we have in a minute. However, the probability that she loses on the first draw is 3 out of the total, which is n. Now, how many black marbles we have? If we have n in total, then this is n minus 5. Notice that if you add all of these numbers, you get n. Now, what is the probability in terms of n that the game will end on the third draw? That means that on the first and on the second, she cannot draw a red marble, which means, and considering the fact that there's no replacement, that she has n minus 3 out of n options in the first draw. And where does that come from? That comes from the sum of n minus 5 and 2, which means that she drew a black or a blue one out of this bag. Now on the second draw, there are n minus 1 options because one of them is not being replaced, which could be a blue or a black. And now we have n minus 4 options, so 1 option less. And on the third, she needs to draw one of the red ones out of n minus 2. We have n minus 2 in total now, that we have 6 black marbles. And Lara is playing the following game. She draws 3 marbles. For each blue marble drawn, she earns 15 bucks. For each black one, she earns 6. And if she draws a red marble, then the game stops. Now, in this case, the probability of losing in her first draw is 3 out of the total, which is 11 now. So the probability of losing on the first is 3 out of 11, which we can represent in this table right here, which we're going to end up filling completely in the next few questions. Now for question 2i, we need to show that the probability of winning $21 is 4 over 55. So we're verifying this result, which is already on the table. And a slight hint was given here, which is for her to win $21, she needs to draw a blue and a black, or a black and then a blue. And for the third marble in each one of these cases, well, it has to be a red one. So she loses and ends up with only $21. And by the way, that's the prize money. That's not exactly the profit because she still will pay to play the game, but that's only for question number 4. Now let's consider these two scenarios, blue, black, and red, which means 2 out of 11, then 6 out of 10, which is the black one. We have 1 marble less, so instead of 11, we have 10 now. And then 3 out of 9. Or, and or in probability means plus, black, blue, and then red, which is 6 out of 11, 2 out of 10, and 3 out of 9, which is in fact 4 out of 55. All right, so let's now complete the table with all the probabilities and the prizes. It's easier to start with the prizes because, well, it's just adding the prizes for each individual marble. So for this case, for example, we have 2 blue and 1 black, which means 15 plus 6, which is 36. Then we have 2 blue and 1 red. The red represents the person losing, which means only $30. And then we can continue from there. So 2 black and a blue, which is 27. Then we have 3 black, and so on and so forth. Now to find the probabilities, I'm going to start with this one specifically just because I want to illustrate the scenario completely so there's no misconception or misunderstanding of what this represents. We have 2 black and 1 blue, which can happen in any order. So 2 black and 1 blue, they are 6 over 11, that's the first black, 5 over 10, that's the second one, and 1 blue, which is 2 out of 9. And there are 3 ways of arranging that, which is black, black, blue, black, blue, black, and blue, black, black. So multiplied by 3, which means 2 over 11. And that doesn't happen, for example, in this case. Because in this case, if we try to put or place the red before, well, the person loses, and this situation does not make sense anymore. The losing portion, which means extracting a red marble, has to be the last one. And also switching the order of the blues, well, it doesn't change anything. So we have the first blue, the second blue, and then the third one as a red one, which is 1 over 165. Now over here we have 3 black, and we cannot do anything with the order here. So 4 over 33. Then we have a blue and a red, 3 over 55, 2 black and 1 red, 1 over 11, and a black and a red, which is 9 over 55. Now let's jump to the last question. Given that Lara pays $12 to play, find her expected profit and explain its meaning. Now, this is the price for each scenario, which does not represent the profit. The profit is for each one of these cases, whatever these are, minus $12, which means over here, 24, and then 18, 15, 9, 6, 3, 0, negative 6, and negative 12, which means that the expected profit, which is a product between the profits and their probabilities, it is equal to 24 times 2 over 55 plus 18 times 1 over 65, 165, plus all the way down to negative 6 times 9 over 55 plus negative 12 times 3 over 11. And the expected profit is positive $1, which means that in average, each person that's playing is expected to win $1. Mr. Galileo bought a remote control car from his son Isaac, and as they turned it on, they were able to plot the velocity of this car in some way, don't ask me, which is represented by this curve. Now this is 8 seconds, and we have a number of points here from A to G. Now, referencing these points from A to G, we need to find where the car is at rest. What does it mean to be at rest? Well, the velocity is equal to 0. In that case, the graph should either be crossing or touching the t-axis, which means, in this case, points A, C, E, and also G. Question number 2. The car is neither accelerating nor decelerating. That means that the acceleration is 0, which means that the derivative of the velocity is 0, which means from this graph that the tangents to the velocity curve, they are flat, meaning they are horizontal. So in this case, we're talking about points B, D, E, F, and also G. Now do notice that in all of these cases, the derivative, which can be represented by the slope of the tangent line, they're all equal to 0. Last question, the car changes direction. An object changes direction when its velocity goes from positive to negative or from negative to positive, which in this case can be represented or is represented by points C and also G. Do notice that E is not a solution, it's not an answer because, well, the velocity before E and after E, they are both negative. So this does not represent a point or an instant where the car changes direction. Now, Mr. Galileo, being the smart guy that he is, he was able to come up with a model for this curve, and there it is. So the velocity can be represented by this function from 0 to 8. If we want to find the displacement, which is, by the way, not the same thing as the distance traveled, we need to integrate from 0 to 8, in this case, the function velocity with respect to time, which you should do using your GDC. So from 0 to 8, you plug in this function, and you get approximately negative 21.4 rounded to 3 significant figures meters. Now, is it possible for the displacement to be negative? Well, if the object ended its movement where the axis of displacement is negative, which means if it's oriented to the right, he finishes on the left, then yes, it's completely possible for the displacement to be negative. We're actually going to draw a motion diagram in the next exercise, and that is going to be very clear. Now, why do we need to draw a motion diagram to find the maximum distance between the car and the origin during that interval? Well, it's easier to see if you do so, and it's easier to explain also if we do so. Now, let's suppose that this object starts at the origin, which is exactly the case over here. Now, if this is the origin, which is point A, by the way, this is where the object or the car starts to move. As we go from point A to point C, the displacement, which is positive, which by the way is the area under this curve, will make this object go to the positive orientation of this axis right here, which means that he's going to do this. He's going to go to point C. Now from C to E, the area which represents the displacement, it is negative, meaning that he's going to go according to this orientation to the left now. Now this is point E, and then he goes even further to the left, and this is point G, and then we have this last area, which is t equals 8. Now I'm just going to label 8 over here. Now it looks like he's the furthest away from the origin at point G, but let's make sure that that's the case. Remember that this is the function of velocity, which means that we have t-intercept at 1, 4, and 7. How do we know that? Well, if you take this function and make it equal to 0, and at 0, by the way, if you make this function equal to 0, that's exactly what you find as solutions, t equals 0, 1, 4, and 7. So points A, C, E, and G, they are respectively 0, 1, 4, and 7. And if you want to find this area number 1 or displacement number 1, you just need to integrate v of t from 0 to 1, which gives you 11.45. So point C is at precisely 11.45 meters from the origin. And now we have this S2, which is the integral from 1 to 4 of v of t dt, which is negative 31.09. Now from here, he goes 31.09 to the left, which means that he is at 19.6 to the left of the origin. We just added negative 31.09 to 11.45, keeping the sign, so that's why we got negative 19.6. So if you want to indicate this as negative, you can as well. Now this area over here, which is approximately 5.57, meaning that we're going to go an extra 5.57 to the left. So this is negative 25.2. And then we go a tiny bit to the right, more precisely 3.85 approximately, which means that when t is equal to 8, we're at 21.4 approximately. Now, right now, we can address the question, which is, what is the maximum distance between the car and the origin during that interval? Well, it happens at g, which is when t is equal to 7, and the maximum distance from the origin that this object reaches is 25.2 meters. All right, so that's a wrap for week number 2. Hopefully you enjoyed the exercises, the challenges that you faced there. If you haven't downloaded it yet, you probably did because you were working on the exercise list. But if you want to find the PDF for this exercise list and also for other weeks, you can find them in the description of this video. And I'll see you next week.